Hello and good afternoon. It's day 2 of Embedded World 2024 and I'm here with Mike Pienovi, Product Line Manager, High Performance Processors of Texas Instruments. Mike, thank you for joining us today.
Thank you for having me.
And we're going to be talking about building smarter, safer robotics and also touch on some automotive topics. So first things first, how is Texas Instruments pioneering the development of smarter and safer robot applications with its innovative embedded processors?
Yeah, thank you for the question and the opportunity to talk with you today. So TI has spent many years developing embedded processors and specifically processor solutions that incorporate some component of functional safety. And as we look at autonomous robots and more automation in factories and with robotics itself, the functional safety support within the devices that are used in those systems, but also in the systems themselves so that they can be deployed in scenarios where they have to be more conscientious of the safety applications that they're doing. Our parts really need to be able to support that. So again, it's been a multi-generational investment and development from TI to make sure that we bring that technology to the table for our robotics customers.
Okay, fantastic. And maybe could you elaborate on some key design challenges engineers face in robotics today and how TI's technology is addressing these issues?
Sure. Yeah, so when you look at the robotic systems, a lot of what is required, specifically when you look at automated mobile robots, is the ability to do the different multimodal detection. So that's really the key technology that's required, is to be able to do the sensing, to be able to understand what the environment around you has there, so that you can then decide, how to adapt or how to make the machine move in a way that's going to be useful, both from an operational efficiency perspective. It has to be able to get around the factory faster, but then also to do that in a safe way, especially now in systems where we see robots and humans, or again, different environments where there's more functional safety and that capability expected in order to deploy the systems more broadly.
Okay, right. And you touched upon safety. Of course, it's paramount in robotics, but can you just elaborate further TI's approach to enhancing safety in robotics? For instance, with the example of your work with Amazon Robots.
Yeah, that's right. So we've partnered actually for almost a decade with Amazon in support of their robotics platforms. And now, again, looking at they've deployed, and we're actually showcasing it in the TI booth, the first of their automated mobile robots called the Proteus platform. And what this does is it takes TI's processors that have vision-based accelerators and deep learning accelerators that allow for the robots to understand the environment around them and basically create a safety bubble so that they can be used in these systems from a functional perspective. And then in addition to that, one thing that TI uniquely has in our devices, we have safety certified products. So our processors are certified up to SIL 3 in the industrial safety context. And that actually enables safe modes and safe failure reactions from our chip, assuming something doesn't go right within the device itself.
Oh, wow, fantastic. Well, with sensors, sensor fusion is critical, or crucial rather, for advanced robotics. How does TI's TDA4VM processor improve vision processing capabilities for such robotic applications?
Sure. Yeah, so the TDA4 family really was designed to give the right balance of processing and compute performance, and then the real-time performance within our real-time cores that we have on the devices. In addition to that, we also have dedicated vision and AI accelerators, so that really helps, again, get the right level of efficiency and performance needed to be effective in those systems. And beyond that, both safety and security, there are actual hardware-based mechanisms within the devices to go and address that. So it's really about having that full comprehensive suite of technology in a single device so that you can get the right level of performance out of the solution, again, to be able to design these systems.
Okay, and talking about motor control, how is TI's work advancing the technologies for more efficient and responsive robots?
Right. So in the context of either motion or motor control, both are critical, of course, for robotic systems. It's one of the most fundamental requirements or technologies that are used to enable them to go where you need them to go and to be able to do that in an efficient manner. And TI has actually invested in the motor control space for decades, and we've been able to bring technology that maybe in the past had been only deployed in microcontrollers or more dedicated control systems actually into our larger embedded processors, so that we bring that kind of mixed capability in. You've got both the high performance compute and the real-time control that gives you the ability to do very high precision motion and motor control. And then of course, do that in a way that's effective. Maybe you have multiple joints in a robotic arm, or you want to be able to move in multiple directions on an autonomous robot. The fact that we've got the right blend of resources on the device allow us to to be able to do that in a very efficient way.
Oh, fantastic. So closing off about the robotics sector, or TI's work in it, how would you summarize TI's work in robotics, and what can you say your solutions are bringing to the sector?
Yeah, I think TI really is looking at how we can be the most efficient solution possible from a processing perspective. That's complemented by one of the most extensive analog and power portfolios in the industry as well. So beyond just the processing side and being able to bring that right blend of safety and performance and real-time control, we do that in a way where there's even system-level benefits by combining multiple TI solutions together. This is an industry that has helped to guide our investment strategies through a number of years now, and something that again you start to see it manifest itself in ways where it's really about efficient systems that give the best operational efficiency to our customers.
Oh, excellent. So let's drive into automotive now.
Sure, please.
So how is TI's work in automotive applications influencing the evolution of smarter, safer, autonomous automotive technologies through its embedded processors?
Yeah, so interesting. The technologies themselves, as you can imagine, are in some ways similar, right? The things that we're doing for advancing the driver assist capabilities or autonomous driving to higher levels, it's really built around the same kind of fundamental components. So multimodal sensing capabilities, so you have things like vision-based, LiDAR, radar, all of those different technologies that give data input or that visual input of the world around us. All of that has to come in, and then once you have that data, being able to do something with that in an intelligent way and have that closer to the edge has been one of the biggest things that we've been able to bring to the table. And it's really a balance of just again, that raw compute performance by having the right technology to bring those data streams in. So you compute that, and then in addition to that, again, especially in these last, the recent years, we've been able to come forward with more and more AI acceleration. So deep learning acceleration that does more intelligent, it allows the cars or the robots or any other technology or system that's going to take advantage of it to be smarter with what it does with that data. So it can do object detection, it can do object classification. Those are some of the fundamental things that are used in that deep learning space to be able to have very safe, very intelligent cars or robots.
Okay, fantastic. In the context of ADAS, sensor fusion is also vital. How does TI meet the growing demand for processing sensor and vision data quickly and reliably in vehicles?
Right. So in our case, we leverage our dedicated and purpose-built AI accelerators to be able to do that fast and efficient data processing. It basically, again, we're able to run different neural networks and models within these accelerators, and it allows us to give, a more intelligent response, right? We can either have, better quality of data or quality of interpretation of that data, and then the deployment of that and the decision-making that we have, again, built all in that context of being functionally safe and secure with all the data and the actions taken from it.
Okay, and for vehicle electrification, accurately reporting the state of charge and state of health is crucial. How does TI's technology help in maximizing drive range by improving these metrics?
Right. So the accuracy that we're able to determine the quality of the state of charge and state of health. I mean, that's really, and we've got both analog and embedded products, microcontroller products that help as a part of this equation. But being able to capture that data at the cell level, be able to give the most accurate and highest accuracy or reliability of what that data is, and then basically run algorithms across it to be able to optimize. That's going to help with the longevity of these battery systems. As we get more and more cells together, the complexity has gone up by quite a lot. So again, the compute performance, the AI and the intelligence behind it, the machine learning there, really has allowed us to take the next step and allow our customers to take the next step in extending the life of these systems.
Okay, fantastic. And your TDA4 family of processors caters to the specific needs of the ADAS system in terms of processing power and efficiently. Can you explain how it does that?
Right. So it's really the intricacies of bringing the right combination of technology together. So we have applications running on our larger ARM-based cores, and then we also have a set of safety and real-time cores that are built around that to be able to help actually take the actions needed in real time, very deterministic, to be able to, again, get the most out of these systems.
Okay.
So those are the most kind of fundamental capabilities that we have. And then we actually build in hardware and software safety mechanisms that allow for the functional safety levels, depending on what level of autonomy might be employed. It allows you to meet all those things. And one of the other unique things from TI's perspective, or in the solutions and the portfolio we offer, we really try to give a very broad portfolio of performance and price points so that our customers can maximize where they can deploy all this technology in more of the entry-level segment of cars all the way up into the highest performance. Okay,
excellent. What about any particular challenges you've had in sensor fusion for ADAS, and how is TI's processors overcome these?
Right. Yeah, so it's partially a hardware component to that equation. And again, we've looked to invest, through the years on getting the right balance of performance at the hardware level. But the other very important aspect of being able to really, deploy and give the technology the full potential in these systems is really the combination of hardware and software. So we have our own software and tools that we use to deploy, again, more of the intelligence on the system as well. And then we also partner with a number of industry ecosystem partners that help in the deployment of the deep learning and AI technology.
Okay, fantastic. And what advancement in TI's embedded processors are most critical for supporting the complex requirements of the next-gen ADAS systems?
Yeah, I think as you look forward, really where the industry is going, you hear people talk about more features within the ADAS space or higher levels of autonomy. And so again, just continuing to look for the right balance of that scalability and the range of performance, whether that's the AI and TOPS performance within the devices, or if it's more on the compute bandwidth and networking performance that's required. That's another critical thing that we see as we look forward in the industry from an ADAS perspective, is also the connectivity and the networking requirements, so that you can do things that, again, many of our customers are requiring now or expecting to be able to do, like software over-the-air updates and being able to upgrade systems dynamically with the software-defined vehicle. So it's really, again, bringing more of those technologies in together and doing that in a very cost-effective and performance-effective way.
Okay, and how is TI's technology contributing to the development of more autonomous and connected vehicles, particularly in the realm of safety and efficiency?
Right. So we certify our devices up to the ASIL-D and the ISO 26262 standard, and then have the ability to support the newest security standards that the automotive industry is requiring now. So those are some things that we are required to bring to the table at the hardware level. And then I think really it's about making our tools as robust as possible. We're very one of the things that TI has invested a lot in is making sure that we are engaged and involved in the open source community, both on the AI side and in general from a software development perspective. So just making that development process easier for our customers has been something that we've put a lot of effort behind to try and give the best solution, total solution possible for our customers to be able to use.
Okay, excellent. And what about TI's collaboration with industry leaders to integrate its processors into cutting-edge automotive applications? What can you tell us about that?
Yeah, so we've partnered with a number of partners, OEMs and tier one partners across the industry, and have been able to give them that scalability that they look for, as I mentioned earlier, really to be able to deploy the right amount of the technology at the right price point to make sense within their car lineups. And so, again, that's something that, I think from the processor perspective is very much, something that our embedded processing organization has done. But then beyond that, again, we look for the complete system, right? We bring companion devices, whether that be for transceivers or power management, other analog solutions that can give the most efficient total solution for our customers.
Okay, fantastic. And how does TI envision the future of robotics and automotive technology landscapes evolving? And what role will its embedded processors play in that landscape?
Right. The intelligence is only going to continue to go up. So I think as you look forward and, we continue to invest in these areas, certainly, very likely that the amount of autonomy will continue to rise. The ability to do that in an environment where it's mixed between machines, whether that be cars or robotics in factories, that will continue to rise. So I think it will be just a continuation, an evolution of these trends that we've seen, where the safety technology and the operational capabilities of these devices to really maximize efficiency, to give higher performance and higher accuracy, will continue to go up and improve.
Okay, great. And I suppose lastly, tell us about TI's partnership with DigiKey.
Yeah, so long-standing partnership with DigiKey, and we appreciate everything they bring to our business model from a channel perspective. Mm-hmm. And yeah, really look forward to continuing to collaborate further with the DigiKey team.
That's great. Well, thanks very much for joining us today, Mike, and wishing you a good rest of the conference.
Really appreciate it. Thank you as well.